Hello everyone, this is question 8 now. So let's have a look at question 8 on this paper 1 from 2024 Edexcel. And we've got a functions question. So it says the functions f and g are defined by f of x is equal to 4 minus 3x squared and g of x is equal to 5 over 2x minus 9. Find f of g of 2. So a nice kind of like straightforward composite function thing for the first couple of marks there. So f of g of 2 just means that we're going to put 2 into f of x. So f of g of 2 is going to be f of g of x, but with 2 in. So it's going to be 5 over 2 times 2 minus 9. So 2 times 2 is 4, and 4 minus 9 is minus 5. So 5 over minus 5 is minus 1. So we need to work out f of minus 1, and f of x is 4 minus 3x squared. So that is going to give us, when we work that out, that's going to give us 4 minus 3 times by 1 squared. So that is going to be 4 minus 3, so that is 1. So that's the answer to question 8, part A. Part B, it says find the inverse of this function. Okay, so let's have a look at finding the inverse. Now, in order to find the inverse, there's various ways that this is taught, okay, and I prefer just to use the swapping x and y over method. Okay, so that's what I'm going to use. So I've written g of x as 5 over 2x minus 9, and then I've just replaced my g of x with y. So I've written y is equal to 5 over 2x minus 9, and here's the swapping over method now. So I now swap over the x and y, which just means wherever there's a y, you change it into an x, and wherever there's an x, you change it into a y. Okay, and then once we've done that, we then rearrange to make y the subject. So we've swapped over, and we're now going to rearrange to make y the subject. So the first thing we're going to do is we're going to swap the positions of these, so we can, like, whenever you've got something equals something over something, you can swap these two over. So that's going to be 2y minus 9 is equal to 5 over x. I'm then from there going to add 9 to both sides, and then I'm going to divide by 2. So I've added 9 and divided by 2. So that could be written as, multiplying that bracket out gives me 5 over 2x plus 9 over 2. And I could multiply the numerator and denominator of this fraction by x in order to just combine it into a single expression there. So that's it done. That's our inverse. So our inverse, g to the minus 1 of x, is equal to 5 add 9x all over 2x. Now notice that it's very often there's a mark for defining the domain, even though they don't explicitly state that in the question. Okay, so you do have to watch out for that. And here our domain is going to be x. It's a member of the set of all real numbers, but we need to exclude x equals 0 from the domain, because if x equals 0 was in the domain, it's going to be, the function is going to be undefined. So we'd get math error on our calculator. So we need to exclude 0 from that one. Okay, that is that's part B done. We found the inverse. So we're 5 marks in. Now let's see what's next. Part C, it says find an expression for g of f of x, giving your answer as a simplified fraction. So g of f of x, again, just like kind of thing we met in year 11. So g of f of x, how we're going to find that is we're going to do g of f of x. F of x is 4 minus 3x squared. So we're going to do 4 of 3 minus x squared. And that is going to go into our g of x, okay? And g of x is 5 over 2x minus 9. So our new quote-unquote x is our 4 minus 3x squared. So we've got 5 over 2 times by 4 minus 3x squared minus 9. So now we just expand our bracket. So we're going to go 2 times 4 is 8, 2 times 3 is going to be minus 6. And we can then collect like terms. 8 minus 9 is minus 1. So that's our expression, okay? That is our g of f of x. We could write it like that. Sometimes it's considered to be inelegant to have negative numbers in the denominator, just kind of like for maths convention reasons. And if that's the case, you could just multiply the numerator and denominator by minus 1, in which case you would write the fraction like this. But either that version or that version are acceptable to get all of the marks. See part 2. deduce the range of g of f of x. Okay, now this is interesting. So let's have a think. And I know that in my experience, students do find this a little bit tricky. So we've got our expression. So this is our expression, okay, for our g of f of x. Let's just write that down so we know that's our g of f of x, okay? And we want to think about what happens. So let's think about what happens when x is very, very big or x is very, very small, okay? So as x tends to infinity, in other words, as x gets like larger and larger and larger, then our denominator is going to become bigger and bigger and bigger. And 1 divided by something that's really big is something really small. So in other words, as x tends to infinity, this graph is going to tend towards 0, okay? So that's one thing that we can be aware of. So let's think about the other end of the spectrum. What happens now when x is really, really small? Okay, so we're going to say x is getting like smaller and smaller and smaller, going towards minus infinity. Well, again, because the x is squared, we're going to have minus 5, but divided by an absolutely huge number. So it's going to approach 0, okay? So yeah, it's going to approach 0. And so we know that kind of, I suspect, I don't know exactly what this graph looks like, but I feel like my feeling is it's going to be something that sort of looks something like that, I would imagine, okay? So we've got an asymptote over here at 0 at minus infinity, but it's approaching it from below. And the same thing over here at positive infinity. So now we need to just say, okay, what is it going to be at the point where x is equal to 0 then? Okay, so when x is equal to 0, maybe it's actually entirely symmetrical like that, perhaps, yeah? So when x is equal to 0, we're going to have minus 5 over 1, okay? So actually, our range of values for this function is that g of x is going to be g of f of x rather, is going to be less than 0 because it has an asymptote at either end there, but it never quite reaches it, so that's why it's a strict inequality, but greater than or equal to minus 5. And it's greater than or equal to because it can actually be minus 5 there when x is equal to 0. Okay, so y is minus 5 when x is equal to 0. I'm going to get rid of that line there. So that's how you would do that one, okay? I mean, this is one of those things really where if you've got a graphical calculator, you're at an advantage because there's absolutely nothing to stop you plotting that and seeing what that looks like. So, you know, definitely advantageous if you've got a graphical calculator for that particular question. Okay, what's next? So we've done that bit. What is next? Oh, right. So actually, I haven't quite finished this question yet. Okay, let's do it now then. So we're going to finish this question now. I thought I'd done all this one, but I haven't done apparently all of it. So what's the next bit? It says, find the range of values for k for which the equation f of x is equal to h of x. Okay, so if f of x is going to equal h of x, let's put them equal to each other to start off with. Okay, so we're going to say that f of x, which is our 4 minus 3x squared, is going to equal our h of x, which is 2x squared minus 6x plus k. So we put them equal to each other. So let's get the whole thing as a quadratic over one side. That's going to give us 5x squared minus 6x minus 4 is equal to 0 when we get it over one side. Now, if these two equations are equal to each other, let's have a think about this. Oh, hang on. It says find the range of values for which there are no real solutions to this equation. So therefore, we're implying that the discriminant, the b squared minus 4ac, is going to be less than 0. So that's what we're after, okay? So our b is minus 6, so minus 6 squared, times by 4, times by a, which is 5, times by c, which is minus 4, is going to be less than 0, okay? So we're going to have 36 in there. Why have I not got a k in there? Let me just have a look. Oh, I know why, because I missed out my k when I was writing that down. So it's minus 6, and then we've got plus k minus 4 there. Okay, so that is k minus 4. So our quadratic equation is 5x squared minus 6x plus k minus 4. So our discriminant, our b squared minus 4ac, is going to be minus 6 squared minus 4 times 5 times by our k minus 4. Okay, that makes a lot more sense now. So that is going to be minus 4 times 5 is going to be minus 20k. And then we're going to have plus 4 times 5 times 4. So 4 times 5 times 4 is 80. So we're going to have plus 80 is less than 0. So therefore we're going to have 80 plus R36 is going to be 116. So 116 minus 20k is less than 0. So therefore 116 is less than 20k. So 116 over 20 is less than k. So in other words, k is greater than 116 over 20. And let's see what that gives us. 116 over 20 is equal to 5.8. So you can either write it as a fraction or you could write it as a decimal. So the range of values for which there are no real solutions is k is greater than 5.8. Okay, that is the end of that question now. I hope you found that helpful, and I'll see you in the next video.